Welcome back to a second question on saturated vapor pressure calculation. So we have a question. So it said air mass is at a temperature of 28 degrees Celsius. So that is the temperature of the air, not the dew point temperature. With a relative humidity. So the relative humidity is 70%, right? Using figure 2.2. So figure 2.2 is simply the equation. This equation that is E is equal to 6.11 times E exponent 17.27 T over 237.3 plus T. Let me do it. I, I. So that is the general equation, right? Yes. Then we are asked to find the saturated vapor pressure, actual vapor pressure in millibar and millimeters mercury. So the saturated vapor pressure, we are supposed to find it in millibar and millimeters mercury. And the actual vapor pressure to the same millibar and millimeters mercury. Then we are supposed to find the saturation deficit and the dew point temperature. Now, what can we find? With air temperature, we can find the saturated vapor pressure, right? Remember the relation. Normal air temperature will give you saturated vapor pressure, and dew point temperature will give you actual vapor pressure. You get it? So if we have temperature, we can find the saturation vapor pressure. So that will be the first thing that we find. So saturation vapor pressure is equal to 6.11 times E exponent 17.27 times T over 237.3 plus what? Plus T. Now let's put in the parameters. So the saturation vapor pressure is equal to 6.11 times E exponent 17.27 times 28 over 237.3 plus what? 28. And this will give us what? So we use our calculator to find out. So this will give us so putting this in the calculator, you're going to get what? 37.811 millibar, right? Okay, with that in place, we can find the actual vapor pressure. Although we don't have the dew point temperature, we can find actual vapor pressure out of the relative humidity. Remember, relative humidity is equal to the actual vapor pressure over the saturated vapor pressure times what? 100%. You get it? So now we are having 70 is equal to actual vapor pressure, we don't know. Saturated vapor pressure 37.811 times what? 100. Right? So we are looking for E. So we can see that 70 times what? 37.811 is equal to 100 watts E, right? And so if I'm going to continue down here, I can see that 100 E is equal to 70 by 37.811 over 100 over what? 100. And so the actual vapor pressure will be equal to, I have to evaluate this. So evaluating it, you're going to get 26.468 millibar. So that will be it. Now, we are supposed to change them to millimeters mercury. So this is millibar. Now, 1.33, 1.33, I'm coming minutes. Let me verify if what I'm writing is right. 1.33 millibar is equal to 1 millimeters mercury. So if I want to change this to millimeters mercury, so 1.33 millibar is equal to 1 millimeters of mercury, right? Then the first one, which was 37.811 millimeters mercury, will be equal to X, so we cross multiply. So we are going to get 37.811 times 1 millimeters mercury over 1 over 1.333, and that will give us X. So X will be equal to, so in this case, X will be equal to 28.365 millimeters mercury. So let me change the color. So for saturated, we have 37.811 millibar, and in millimeters mercury is 28.365 millimeters of mercury. Then we do same for the actual, right? So the actual, we have 26.468. So it will be times 1 millimeters mercury all over 1.333. That, let's say, is Y. So we are going to get Y to be equal to. So that one is going to give us 19 point 19.8 what 856 millimeters of mercury. So in that case, the saturated in millibar is, sorry, the actual vapor pressure in millibar is 26.468 millibar. Then in millimeters mercury is 19.856 millimeters mercury. All right. Now we can proceed to the C, the saturation deficit. Now saturation deficit is simply equal to the saturated vapor pressure minus the actual vapor pressure. So this one we can leave it in any unit. So we are using the millibar unit. So the saturated vapor pressure is 37.811 millibar minus the actual, which is what 26.468 millibar. And so the saturated deficit will be equal to, so we are going to get 11.343 millibar. Then the last question is to find the dew point temperature. So that's the last thing that we're going to look at, the dew point temperature. Now we can only get the dew point temperature from the relation E equal to 6.11 times E to the power 17.27 T over 237 237.3 plus 1 T. Now, if we are looking for dew point, then means we need actual vapor pressure. So the actual vapor pressure, which is 26.468, is equal to 6.11 times E to the power 17.27 TD, the dew point, over what? 237.43 plus what T will be. So I can divide it by 6.11 divided by 6.11, right? So I'll get 26.468 over 6.11 is equal to E exponent 17 point what 17.27 TD over 237.3 plus of TD. So we are going to get 4.31 sorry 4.331424 is equal to E to the power 17.27 TD over 237.3 plus 1 TD. Right. Now with this input, we have to find length of both sides. So I'll see that, let me continue from here. I'll see that length of what? 4.331424 equal to length of E to the power 17.27 TD over 237.3 plus TD. Now length of this will give us length will give us 1.465896, right? Is equal to this logarithm, so the power will come out. So when the power comes out, 17.27 TD over 237.3 plus TD equals Now length of E is what? 1, right? Then natural log of E is 1. So we are going to get 1.465896 is equal to 17.27 TD over what? 237.3 plus what? TD. So I cross multiply. I'm going to get 1.465896 multiplying 237.3 plus TD is equal to 17.271 TD. And so when I multiply, I'm going to get 1.465896 multiplying 237.3 plus 1.465896 TD is equal to 17.27 TD. So I group like this: 1.465896 multiplying 237.3 is equal to 17.27 TD minus 1.46896 TD. 1465. Let's write it. So I'm going to get 1.4659896 multiplying 237.3 equal to, so TD out will be left with 17.27 minus 1.4659896. So I will divide both sides by this, right? So 17.27 minus 1.4659896. So 17.27 minus 1.4659896. So this will cancel this. So we are going to get TD to be equal to this. So let's see. Let's see what we get. So per computation, you're going to get TD to be equal to 22.0.0105. So I can see that TD is what? Is 22.0.0105 Kelvin. Sorry, degrees Celsius is in degrees Celsius, or which is approximately 22 degrees Celsius. So yes, this will bring us to the end of this question. The next question we look at is the graphical method, and we see how we go about it. Thank you for joining. Bye. Make sure to subscribe, like, and share to your colleagues. See you in the next video. Bye.